Welcome to High Examine, and today we're going to be looking at methane. Methane comes from cows. It comes from both ends of cows, and it also comes from humans. And it turns out that methane is created whenever you have anaerobic digestion of organic matter. So think of it as any time that buggers digest organic material when there's no oxygen present. That's when you get methane, and we're going to talk about the implications of that on the environment. So this is what a methane and CO2 look like in terms of their global warming potential over a 100-year time period. You can see methane starts with a dramatic impact for the first few years, upwards of 100 times that of CO2, and then it tapers down to much lower than CO2. And then CO2 has nearly a flat line for 100 years. And it turns out that CO2 has the problem that it really doesn't go away very quickly, and it retains this radiative forcing for upwards of 1,000 years plus. So if we take the average of methane across the 100 years and compare it to CO2, it's about 25 times greater, and depending at whose data you look at, 25 times greater or more. So it's a significant impact. And now if we start to look at all three of these leading greenhouse gases together, we've got carbon dioxide, methane, nitrous oxides, and there's also secondary and tertiary greenhouse gases that are not represented here. And the key is that look at this giant spike in the last 100 years, and this is data only going back to 2005. We need to get a more up-to-date data set, because now we're upwards of 415 parts per million of CO2. So the red line should be upwards of here off the chart. And the problem with this is that people typically cite the CO2 number. We started at 280 parts per million pre-industrial, and now we're at 415, and that's all they talk about. 415, 415, 415. However, you need to include these other additive greenhouse gases because these are stacking one on top of the other. And it turns out that if you add them to the warming effect, you can create something called CO2e, or equivalence. And that means that you make the methane warming equivalent in CO2 warming, and you add it to the baseline CO2. And you can do that with all these greenhouse gas emissions, and you'll get something over 500 parts per million. So again, we're not really at 415 parts per million CO2. We're really at 500 plus parts per million CO2 equivalents. And the implications of this are significant, and that's why we're seeing such rapid warming. And that rapid warming is causing the permafrost in the Arctic. So again, the Arctic is ground zero for climate change. And what you see here in bright purple is the permafrost layer, and then kind of some transitional layers around it. And what's happening is this is melting back year on year as things warm. This permafrost recedes. And how it ties back to methane is that there's a bunch of organic matter in the Arctic because it used to be much warmer. There used to be forests, there used to be crocodiles, and all of that has not gotten melted out in the past. So it's still frozen in the permafrost layers, waiting to be digested into methane if there's no oxygen present, or CO2 if there is oxygen present. So the end result is you get a greenhouse gas emission either way you go, and you really don't want to thaw back these layers because there's a ton of carbon in here. There is the potential for a significant impact on our atmosphere as this permafrost distribution rapidly changes. And this is representative of the warming across the globe. So if you look at the Arctic, we're always talking about the Arctic and how it's so important to understand. And the reason is in part because that's where the most significant warming is happening. If you take the average warming across the globe, the analysis usually leads to numbers in the 2 to 5x that average number in the Arctic. So we have something called Arctic amplification, which is if you go up, say, 1 degree Celsius across the whole globe, you might see places in the Arctic that are experiencing a 5x increase or 5 degrees Celsius increase. And the reason, there's a host of reasons, but one of them is the heat from around the planet is distributed into the Arctic, and it's a relatively small place that provides the cooling of our atmosphere. And then you also have things rapidly changing like the permafrost, the Arctic sea ice, as well as the snow on the land itself. So taking a look at the implications of that melting permafrost, not only do you get emissions, you get roads that are falling apart because the foundation that they were built upon is no longer rigid. The permafrost melts and goes soft and the road falls apart. This also applies to houses. You may have seen images of houses where their foundations are failing, and that's all due to permafrost receding. In Russia, along the Yamal Peninsula, there are a number of these explosive craters. This is where greenhouse gas emissions have gathered. So you have like CO2 and methane pooling in the ground, and it blows up when it builds up so much pressure and pushes out a bunch of dirt. And these are quite big. They're tens to hundreds of feet across, and they're starting to occur at an increasing rate as the permafrost continues to melt. And speaking of melting, I touched on this earlier. We're not only melting the permafrost, we're also melting the snow that sits on top of the ground. And this can be shown by looking at the Iditarod sled dog race. This is the old route, the original course to Nome, Alaska. And they've had to change it a few times to starting in Fairbanks, further north, because there simply was not enough snow for sledding. And this is a problem because it changes the reflectivity of the surface of the earth. As you can see here, when you have this extensive snow cover during winter, this really reflects back a lot of the light. The albedo of snow is dramatically higher than that of soil, meaning you reflect back a ton of sunlight, and it reduces the amount of warming that's absorbed into the Earth system. And then in the summer, this is receding back. It's not forming as well as it should in the winter. And the end result is you get that dramatic increase of warming that we're seeing in the Arctic. This is one of those positive feedbacks that further feeds the warming of the permafrost and the emission of more greenhouse gases. So we're playing a bit of a dangerous game here. It's like getting one of these gremlins wet. You just don't want to mess with heating up the Arctic. And that seems to be what we're good at right now. Speaking of things that we're good at, recommend in the meanwhile, doing a little shopping, stop by the Gucci store, remain calm, and enjoy a churro on me at the mall. So, these things are important, but don't stress too much, because it's a challenging situation, and we're just going to have to do the best we can. But I do agree with what Spock is saying here. To destroy your home planet's ecosystem for imaginary wealth, such as what's spent at the mall, is highly illogical. So I think we need to make some very rapid changes. Thank you again for joining me on High Examine, and I look forward to sharing future topics with you. Please subscribe and click the bell.